Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and I am hooked on This Is How We Do It. I think this is going to take us all the way home, because in Mathematics SL, the class of 2014, you know how to do it, and you are going to jam on it on Tuesday and on Wednesday. Make us proud. All right, so this is Math Exam Jam number 11, the solution. Problems 2, 3, and 4. Hopefully it wasn't too bad for you. Okay, on the grid below, sketch the graph of V, clearly indicating the maximum point. So we're supposed to, well, let's make a note. 0 less than or equal to t less than or equal to 25. That's the domain. We don't go anywhere beyond that. We look at our scale here. It looks to be in 5s. So that's what I'm going to do on my calculator. Okay, so we have 15 root t minus 3t. I had to write it down so I don't have to go back and forth. Let's go to the calculator. I'm going to go to a brand new screen, start over, and let's add a graph. And we are going to graph 15 square root x, remember to use x, not t, don't get into a panic there, minus 3x, kaboom. Okay, ooh, that doesn't look too good now, does it? So that's because we need to go to our window, right? So window settings, so we're going to go 0, 25, scale of 5, 0, 25, scale of 5. Always make your graph look like the grid that they give you, and then it's very nice, very good. It also said clearly indicating the maximum value, so we need to find the max. Analyze graph, maximum, ooh, that's hard. We go to the left of the max, we go to the right of the max, there we go. 16.25, 18.8. So I'm going to shrink that down a little bit. And I'm gonna copy it for myself and put it over there because you guys have it in front of you on your screen. I don't. Okay, so I'll move that over. All right, so we want to get as close as we can, and I think it's a good idea to put some little guide marks. We know we're at 0 here, and we hit 25. Don't go over here, you'll count off points. And the max is at 6.25, 18.8. So that's about right here. 15, 18, I don't know, maybe about there. And that's about really all you need. And you just try and do it. I don't know how this is going to go. And then it's a nice, smooth downfall. Oh, no, that's not very smooth, but I did okay. And we are going to put that in just like that. Easy points, right? Just copying what you see on your calculator. All right, let's get rid of that. Write down, okay, let d be the distance traveled in the first 9 seconds. Write down an expression for d. So bi, d is equal to, well, what is this? This is the velocity. And the relationship between velocity and distance is the derivative of velocity. Acceleration, no, hold on. Velocity is the derivative of distance or position. Acceleration is the derivative of velocity. Let's write that down just so you remember. So V equals S prime, position, and A equals V prime. So that means that the integral of A equals V and the integral of V equals S, or position or distance. So the distance is just going to be the integral of the velocity function. It says for the first 9 seconds, so it's from 0 to 9, and that will be 15 root t minus 3t dt. And we're going to crank that into our calculator. So I go to my calculator portion. Let's blow that up again. So I'm going to do menu, calculus, numerical integral, 0, 9. And if you have graphed it, you don't have to type in the function. Which one? It's F3. If you don't want, you can type in this function. But if you already graphed this, if you type in F3x, you don't have to retype that thing. Isn't that awesome? F3x dx, easy, bam, enter, 148.5, yes? And of course, we shall round that to 3 significant figures. So that is approximately equal to 149, what's our unit? Meters. Done like a bun. What about BII? Hence, write down the value of D. Oh, that's what I just did. Sorry. I jumped ahead, didn't I? Okay. So that's 149 meters. Don't do it by hand. Write down paper 2. Do not integrate anything by hand in paper 2. Obviously, you have to have the bounds to be able to do that. If you don't have the bounds, then you have to integrate by hand. All right, next problem. Sequences, baby. Sequences. Let's go get our formulas just to be safe. Okay. Sequences and series. Series is a sum of a sequence. There they are. Booyah. Let's put it right here. Wham, bam. Thank you, ma'am. All right. Let's move it out of the way. I like to move it. Sorry about that. Okay, so write down the common difference. Write it down, boys and girls. Once you simplify an arithmetic sequence, the coefficient of the variable is the difference. D equals 2. All right, BI. Given that the nth term of the sequence is 115, find the value of n. Oh my goodness, I can't believe that's a question. 115, we're just going to do 115 equals 5 plus 2n. U sub n equals 115. We solve that, 5 plus 2n, and we subtract 5, divide by 2, we get n is equal to 55, I hope. And then the final part, for this value of n, find the sum of the sequence. So it's asking for the sum of the first 55 terms of this sequence. Yes? Okay, sum of n terms of a geometric sequence. Guess what? I'm going to use this formula because it's the easiest one, and I know the last term. The 55th term is 115. So this is going to be 55 over 2. Okay, plus, we know the last term in this particular series is 115, and all I need is the first term. Well, the first term I can easily get using my formula. U sub 1 equals 5 plus 2 times 1, which is 7. Okay, so we get 55 over 2 times 7 plus 115, which is equal to 33.55. Which is a good answer because it's exact right on, and you might think, oh, we're supposed to round to 3 sig figs. They'd still give it to you if you rounded it to 3 sig figs, which is 3360. But, you know, for sequences and series, just leave it as the actual number. Okay, one more on this exam jam, number 4. Oh, so easy. We got 2 vectors, right? Let's go get, and we got to find the angle doohickey. Let's go look in our formula sheet where vectors are. I think it's topic 4. Yeah. And I'm just going to copy all those cowboys. Here we go. Bam. All right. And so we know the angle between V and W is pi over 3. Okay. So that would be theta right there. Yes. And we got to find the value of k. So let's see how this works out. So we know cosine theta equals v dot w over magnitude of v times magnitude of w. All right, so we know that theta is pi over 3. So cosine of pi over 3, that's a bad 3. Quickly, what's cosine of pi over 3? If you didn't say 1/2 right away, don't tell me. I don't want to know. It is indeed pi over 3. Cosine of pi over 3 is indeed 1/2, I should say. Dot product. 2k, 2 times k, plus negative 3 times negative 2 is plus 6, plus 6 times 4 is 24. I'm going to right away clean that up and say that that is 30 over the magnitude of these two vectors. So just to keep things simple, magnitude of 2 squared plus negative 3 squared plus 6 squared is 49. How about that? 4 plus 9 is 13. Plus 36 is 49. Good. Times the square root of k squared. And 2 squared is 4. 4 squared is 16. 16 plus 4 is 20. So that's plus 20. And of course, the square root of 49 is 7. Okay. And we know cosine of pi over 3 is equal to 1/2. It's equal to 1/2. Yes? So I'm just going to put 1/2 there. How could graph it? Graph. Sketch the graph. So sketch the graph of 1/2 and then 2k plus 30 over 7 square root k squared plus 20. All right, to the drawing board we go. Let's just add another graphing page. Just makes life a little easier. Add graph. So I'm going to go 1/2. Bam, there it is. And then I'm going to hit tab and I'm going to graph this rational exponent. And that's going to be 2k or 2x plus 30 over 7 times the square root of x squared, don't put k, plus 20. Bam. Okay, and it looks like they intersect way down there somewhere. So then it's looking to go below. I just dragged it, or you can do your window. Let's find the intersection, menu, analyze graph, intersection. I'm not sure. I'm going to go way left and then way right. Click. And I get x or k equal to 18.8. Okay, and I'm going to take a quick little picture of that because we need to sketch that graph. All right, and I'm going to go back here. I'm going to paste it just to show you how, what you need to do to sketch. So we get k equals 18.8. And you need to sketch the graph. So I don't know, something like this. And you have, you can go this high. This is y equals 1/2. And then it's very close, you can just go like that. Boom, and you're good. 18.8, 0.5. And that's it. All right. That is all we have. Let's see if this is still how we doing it. I think it probably is. It is. Oh yeah. This is how we do. Are you dancing? If you're not dancing, you should be. Hope you enjoyed it. I am out.